Welcome to our second video topic, which focuses on the properties of numbers. This is chapter 1-3 in our textbook, and it is on page 16, properties of numbers. Now, in this section, there are 4 key properties that we'll be working with. One is the reflexive property. Basically, the reflexive property says that any quantity is equal to itself. So, 5 equals 5, 4 plus 7 equals 4 plus 7. And those things are true all the time. The next property that we'll be working with is the symmetric property, which says that if one quantity equals the second quantity, then the second one is equal to the first. So basically, if 8 is equal to 2 plus 6, then 2 plus 6 must also be equal to 8. Now, these two properties, the reflexive property and the symmetric property, are pretty obvious. I think most of us take those for granted. The next one is called the transitive property. In the transitive property, it says that if one quantity is equal to a second one and the second quantity equals a third quantity, then the first one equals a third quantity. So this is a little bit longer, but still will help you out when you're solving some problems. So basically, if 6 plus 9 is also equal to 3 plus 12, and if 3 plus 12 is also equal to 15, then you know that 6 plus 9 is also equal to 15. So here you have your first property, and you have your third property, and they're linked by a second property. Kind of like if I'm friends with Miss Fisher, and Miss Fisher is friends with Miss Bales, then if we were mathematical quantities, I would also be friends with Miss Bales. Now, I'll leave it up to you to decide whether the transitive property applies in our case. Let's go to our last property, the substitution property. And this says that any quantity can be substituted for its equal in any expression. Now, this is one that we've already used, actually. If you have an expression 4n is equal to 4 times 11, and you know that n is equal to 11. Sorry, if you have an expression 4n and you know that n is equal to 11, then you know that that 4n is also equal to 4 times 11. Basically, it says you can plug numbers in for variables. Now, you wouldn't be able to use variables at all if this property weren't true. So this is another one that we pretty much take for granted. There are a couple of quick properties of addition, so let's distinguish between these. These guys are the properties of equality. They tell what things are equal to each other. Now, there are a couple of properties of addition that will be useful. One is the additive identity. And that says for any number a, the sum of a and 0 is also a. So you have a number 2, you add 0 to it, you also get 2. Or you can also write it in the opposite direction, 0 plus 2 equals 2. Again, something that we take for granted, but math really wouldn't work if this weren't true. So you can also use the additive inverse property, which says that a number and its opposite are additive inverses of each other. This helps you a lot when you're dealing with positive and negative numbers. If this property weren't true, then negative numbers wouldn't work. This is basically how negative numbers are defined. Let's come up with an example. Generally, you could state this as a plus negative a equals 0. I move in the negative direction, and then I move the same distance back, and I'm once again at the 0 on the number line. I could also say it more specifically as 3 plus negative 3 equals 0, or I could say it as 3 minus 3 equals 0. Any order you want to write it in is fine. So let's label these real fast. These are the addition properties. There are a few properties that we're going to find really useful for multiplication too. These are called the multiplication properties. The first one is the multiplicative identity, which says that for any number a, the product of a and 1 is a for itself. Let's write down an example. So a times 1 equals a. True for a number, true for any variable. Basically saying that if I did 14 times 1, that would still come out to 14. Again, a property that we pretty much take for granted. Let's try the multiplicative. These are my quote marks. That means I'm writing the same thing below. The multiplicative property of 0 for any number a, the product of a and 0 is 0. So a times 0 equals 0. Specifically, 9 times 0 is 0, or 0 times 9 is 0. Another thing that we pretty much take for granted. So we can also try the multiplicative inverse. Now, this one says that for every number a over b, where a and b are not equal to 0, then there's exactly one number, b over a, such that the product is a multiplication of a over b and b over a is equal to 1. So specifically, if you take a fraction like 4/5 and you multiply it, say you wanted to get it to 1, you multiply it by itself flipped over, you would end up getting, and we can see why this works out, 20 over 20, because you always multiply across. You would end up getting 1, and that works for any fraction whatsoever. This is one that you might be less likely to take for granted, and one that you'll find useful over and over again. So you're going to want to remember the multiplicative inverse. And let's label these. They are the multiplication properties. Now, why do we not bother with subtraction and division properties? Well, they're basically just the reverse of addition and multiplication respectively, so we don't have to worry about needing those properties. Let's use what we've learned to try our first example. This example is on page 17 in your textbook, and we'll tone over so that it is once again at the top of our page. Example 1 says that we need to evaluate 7 times 4 minus 3 minus 1 plus 5 times 1/5, and this is the key, name the property that we use in each step. So let's try this. These are pretty much problems that you'd be able to do with no issue if you didn't have to name the properties. But we'll go through and name the properties that we use as we go along. Now, if you are in finance or engineering or most fields, you won't have to remember the names, but it's difficult for explaining things. Theoretical math majors want to become a mathematician, it'll probably be useful. But we mostly are going to use this exercise to familiarize ourselves with the properties, and hopefully understanding why the rules of math work the way they do will help you remember them when you need to use them. And you will need to use them. So we're going to do this. Now, we're going to write it again. 7 times 4 minus 3 minus 1 plus 5 times 1/5 is going to be equal to, let's try to simplify it. The first thing I would do is simplify 4 minus 3. I would say that I'm using substitution here. And I'm substituting 1 for 4 minus 3. 4 minus 3 is equal to 1, so I'm going to put a 1 in there. 7 times 1 minus 1 plus 5 times 1/5 is equal to our first expression. What are we going to do next? Well, I know that 7 times 1 is itself. That is the multiplicative identity. Basically says that 7 times 1 equals 7. Using that, I'm going to write 7 plus 5 times 1/5. What can I do next? Well, I can use the property of multiplicative inverse. Let's try that. I'm going to write down the title again of the property that I used because it told us to. Multiplicative inverse. Where when I say that I'm doing the multiplicative inverse, I'm talking about 5 times 1/5, and that comes out to 1. So I'm going to write 7 plus 1. Now, oops, I forgot a step. Let's go back and fix that. We wanted to do 7 times 1 minus 1 plus this, but I wrote it wrong. So we're going to do 7 minus 1 plus 5 and 1 times 1/5. Which means that we have now 7 minus 1 plus 1, because 5 times 1/5 is 1 according to the multiplicative inverse. Now, I'm going to use my order of operations again. First, second, and then third. And when I do that, I'm going to simplify using the fact that 7 minus 1 equals 6. So this is, substitution. Which gives me 6 minus 1. And again, I'm going to use substitution to say that 6 plus 1 equals 7. And our answer to this problem is going to be 7. I'll put a little box around it. So just keep in mind that these notes are also part of our answer because it told us to name the property. So I'm going to say substitution, multiplicative identity, multiplicative inverse, substitution, and substitution again. Those are also part of our answer. You don't have to put boxes around those, but it helps us know what we were going to do. Now you can use this to help you solve the examples in 1A and 1B. But instead of doing that together, let's go on to example number 2. So, in example number 2, we are going to need to use a couple more properties which get introduced along the way. So we're going to have some notes on that. The first one that we need to know is called the commutative property. And this one basically says that I can add or multiply numbers in any order that I want to, and the product is going to be the same. So just like 4 plus 8 is equal to 12, 8 plus 4 is also equal to 12, and 7 times 11 is 77. Well, that's also equal to 11 times 7. The order does not matter. And then the associative property is I would say, less obvious. Commutative property most of us know about, but the associative property can be a little bit trickier. Basically, the associative property says that as long as you're adding or multiplying, it doesn't matter where your parentheses are. Basically, what numbers you associate with the other numbers. So we're going to do an example. If I have the set of numbers a plus b plus c, that's the same thing as a plus b plus c. I can add them in any order I want to. Or, to get more concrete with it, 3 plus 5 plus 7 is the same thing as 3 plus 5 plus 7. The same thing is true when I'm multiplying. Basically, a times b times c equals a, and then in parentheses, times b times c. Again, getting concrete with it. 2 times 6 times 9 equals 2 times 6 times 9. Does not matter where I put those parentheses. Any order is fine. We're going to need to use this in real-world example number 2. So, I'm going to write example 2. And this one says that Eric makes a list of items that he needs to buy for a party and their costs. Find the total cost of these items. So I'm going to write find the total cost. This is just our little note so we don't forget where we are. Now it's provided in a little table for us how much he thinks each thing costs. So balloons are $1.75. Decorations are $14. Food for his party is going to cost $23.25 total. Maybe he's shopping on Peapod. Otherwise, how will he know what they cost? Beverages are going to be $20.50. So knowing all this stuff, he's going to figure out how much everything costs. And the easiest way to do this without having to use a calculator is to actually use some of the properties of numbers. So I'm going to write everything down in order that he has to buy with the cost. So he buys the balloons for $6.75, and then he buys the decorations for $14, and then he buys the food for $23.25, and then he'll buy the beverages for $20.50. Now I know that when I'm adding these, it's going to be a lot easier if I can add these two first and then add these two. We're going to write down exactly what we're doing here. So I'm going to change the order. I'm going to write down $6.75 plus $23.25 plus $14 plus $20.50. Now what did I do there? Well, that was the commutative property of addition. And then I can group them together if I want to and decide to add some of them first. $6.75 plus $23.25 plus $14 plus $20.50. When I do that, that's the associative property. Basically, if I wrote them all like this, that would imply that I'm going to add this one and this one and this one and this one. But if I put parentheses, that means I'm going to add this one and this one, and then separately I'm going to add these two, and then I'll put them back together. So the fact that I can do that comes from the associative property of, again, addition in this problem. Well, when I do that, we can now add these in our head, because 23 and 6 is 29, and then 75 cents and 25 cents is $1, so this part is going to come out to $30. And this part is going to come out to, well, 14 and 20 is $34, and then here, 50 cents. So the fact that I can do that comes from substitution. And then finally, I'm going to get the final answer, $64.50, which is, let me add our dollar sign as our final answer. That comes from substitution again. In that way, math is kind of like a game where it describes the real world, but at the same time, mathematicians make up the rules that we can use to manipulate numbers. And they do it in such a way that you always get to the same final answer. Now, a cool thing that means is that you can make up your own rules to your own game, such that you're creating a whole system of things that work, which is kind of what programmers who develop games do. They make up the rules, they program the world, and then when they're finally finished, they have a really fantastic game. Well, let's see if there's anything else we need to know in order to really use these properties. Well, there's another example that we can use, and that is example number 3. Once you've gone through all these 3 examples, the homework should not be too difficult. So let's go back, turn the page, and we're now at example 3. So using example 3, says we need to evaluate, that means find the final answer. 5 times 7 times 4 times 2, using the properties of numbers. Once again, can't do it in your head. That's okay. We're going to show our work, and we're going to name the property used in each step. So let's write it out. 5 times 7 times 4 times 2. Let's plan how we're going to do this in our head. Tricks are helpful when doing math in your head. Well, I think that for me, 5 times 2 is easiest to remember, and 7 times 4 is easiest to remember. So I'm going to multiply those first. So let's change the order around. This is going to be equal to 5 times 2 times 7 times 4. The fact that I can do that comes from the commutative property of multiplication. And then I'm going to group them together, because as I said, 5 times 2 and 7 times 4 are a lot easier to multiply. That would give us 10 and 28, and then I know I can get the final answer in my head. So that comes from, guess what? Yes, the associative property of multiplication. Well, once we've associated them, it gets really easy to solve this. That's 10, and that's 28. Now, all this mental math wouldn't work if it weren't for the substitution property. And once we've done that, we get our final answer, 280, which once again comes from substitution. So now that you know all that stuff, it should be relatively easy to answer at least the basic problems on your homework. So go ahead and give those a shot. Homework starts on page 19, and when you get back to class tomorrow, we'll try out some of the more tricky ones together. So best of luck.